What happened? Oh, so okay, here. So in that case, I just okay. Equation 1, huh? It is okay. So now look, what I do here. The phase changes in the modified one, modified ADM. So modified ADM. Okay. So in the modified ADM, we just divide function into 2, or we can divide into 3 or into n. So actually phase modification is actually started from the 2. Okay. So now when we substitute the series into here, into the 1, so we have on the left side just as usual u0 of x, u1 of x, u2 of x, and etc. equal f of x plus lambda integral from a to b. Sorry, here not f of x now. Here f1 of x and plus f2 of x, because a function is divided into 2. So k xt u0 of t dt plus lambda from a to b kxt. Because of linearity here, we have very simple t dt plus and so on. So now look, what is the changes? u0 of x is f1 of x. You see, just part of the function we choose. As a u1 of x, we choose f2 of x plus lambda a to b kxt u0 of t dt. Now, the rest is the same. I just put here uk of x. So uk of x is just lambda integral from a to b kxt uk minus 1 of t dt. So here k starts from 2. Actually here, in here, I can say can start from 1. Can k start from 1 because 1 is the first case from 2. But here it must start from 2. Do you see the differences? Differences, you see, the u0 is part of the f function, and u1 is the rest of the part of f of x plus first known or first initial guess function. Actually, choosing this initial guess really in the approximation or in the all type of semi-analytical method plays very important role, especially when we solve the nonlinear problem. It is more important. For the linear case, okay, we have more choice and more easy for calculations, so this is okay. But in the nonlinear problem, it is very, very important. Anyway, so now you can easily see the differences between modified ADM and standard ADM. So in the standard ADM, we have U0 separate, then second one UK, okay, for all K from 1. So in the modified one, we have to start 3 liners, initial guess, then first iteration, then rest of the iteration. Now you will see, I will show one example. If we solve it using the standard modified ADM, standard ADM, it gives very long way exact solution. With the modified one, straightforward, very fast. So that's why actually previously, in the previous class, actually I have shown already one example from here. The first example in the previous class we have discussed it and we found the exact solution. Okay, let me at least two examples. In that case, example 2, this is for standard, and maybe we can solve with the modified one, but we solve as standard. The second part, I will explain one example with the standard one and the modified one. Then you will see the advantages of the second one or modified one, okay? So now let me show the example. So actually, this book is written in such a way mostly for the beginners. So therefore, he gave very interesting examples, simple examples, and solution. But of course, the proof, theoretical investigations is not shown. Later on, we will discuss, but at the moment, we just see the only simple calculations. Okay, anyway, so let me solve example 2, okay, because example 1 previously we have done. I think it is example 1 is more simple, so therefore I will start from example 2. So our equation is cosinus x plus 2x plus integral from 0 to pi x t u of t. All the students, magister students, PhD students, please, you solve this equation using which method? We have already discussed it. Kernel separation method, and we have learned iteration method. Now we are learning other decomposition method. So please, you solve the same problem with 3 methods. You will see advantages of the method, okay? So because it is already, we can see this is a separable kernel, so we can use the first method. Anyway, so how we solve it using currently standard solution, the standard ADM. We use standard ADM. Okay, according to the scheme, I just, you know, you can see immediately, I hope here nothing difficult, because I don't want to, you know, search the solution in the series form, then equate both sides. Just we go to the scheme. Scheme says the u0 of x is chosen as a function on the right side, f of x. For this case, I have like this. So uk, actually now I have to, not uk, one by one, I have to see the trend of the form. So it is, as we know, lambda, actually lambda here is equal to 1. So therefore here we don't put any lambda value. So xt kernel, we don't touch. Then u0 of x. u0 of t means this is cosinus t plus 2t dt. Okay? So now you can easily have seen, we divide this integral into 2. One integral is, the x is out, t cosinus t dt plus x integral from 0 to pi, and here also 2, and t square dt. Okay, by computing this one integration by parts, then this is straightforward. We will get this answer. I hope that nothing difficult. I just write the resulting one, x cube, pi cube, x. So this is a u1. Now u2, we compute u2 of x. So u2 of x is lambda, lambda is 1, from 0 to pi, kxt, that in our case xt, u1. For the u1, I will put minus 2 plus 2 over 3 pi cube t dt. Now, from here, you can easily see if we solve this equation. Okay, let me have. So I need u1, u0. Okay, from here, I think enough. So if I solve this this integral, I just write the final one, okay? Because this is easy computation, minus 2 over 3. But as for you, you have to calculate pi cube plus 2 over 9 pi to the power 6, then x. Actually, x we can factor out, then the rest is just simple solution. Yes. So then u3 and so on. Now, actually, can I see from here trend? You look, every time the second term here with positive, here with the negative. Then we have 2 is you see 2 over 3, 2 over 9, and pi cube, pi to the power 6, actually pi cube square. Next one will be, let me write down one more term. Okay, so I just write negative of this term, pi to the power 6, plus, so now actually better here, one more. If I want to write, so here I should put 3 square, okay? 3 square. So here 3 square. Then here 3 cube. So this one pi cube to the power 2. So now here pi cube power 3. Okay, so in general, I can write uk of x is, look, here 3, here 3 power 3 power 2. Can I generalize in this form? So 1 is plus, 1 is minus. Here square, here cube. So I hope if it is so, I can say 2 over 3 k minus 1 pi cube k minus 1 plus 2 over 3 to the power k pi cube to the power power k. I think it is okay, correct. So generally, if we so what is the solution? Solution u is a summation of uk, or here k from 1 to, actually in general it is infinity, but usually we stop at point n. But for this case, we no need to stop at point n, because you will see u0 is cos 2x plus 2x plus minus 2 plus 2 over 3 pi cube x. Okay, now let me continue this way. Then I will summarize later. So, okay, let me first write down, then summarize. Okay, so I will hold this. Okay, next u2, yeah, sorry, u3 plus u3 plus U3 is, now I can write, because to see the this pattern, it is better to write U3. U3 is minus 2 over 3 square, yeah, because this 9 is a pi to the power, okay, 6 plus 2 over 3 square, yeah. Actually, it is better to write this one square cube. Okay, pi cube square, actually pi cube square. So here pi cube power 3. Okay, plus and etc. So from here, you can see when we open up, this 2x cancel. When we open up, we have canceled with this one. So sorry, 2 over pi cube. This is pi cube. So minus 2 over 3 u2. That one is u1. U2 is, sorry, here I did wrong. U2 is pi cube. I don't have this. This is actually next term. Sorry, I wrote wrongly. So this is 2 and so on. So there, you see pi cube with a pi cube. This term will be cancelled from the next term and so on. So at the end, I just can say it is equal to cos 2x, cos 2x. And interesting point, we can check that this resulting function is a solution of the original equation. You can just substitute on the left side and the right side of the equation and check. You see cosine x cancel. 2x will be cancelled with the next integration problem. So it satisfies the equation. So we got exact solution. Now please, you check by iteration method. Previous method. You will get, but you have to also compute the series. You will get it. But this method is much more easy, you know, is much more easy. So this is the one of the proof that Adamian decomposition method gives exact solution for certain problems. Particularly for the equation 26, it gave exact solution. Okay, now I will check. Here there is an example 3, I think example 4. Now, actually the 3 examples. After that, modify decomposition method. Now let me solve one example. You see, already derivation. U0, U1, U2. Shortly we write U0, U1, and UN. Okay, so already we have done. So